Hi everyone and welcome to another Dech Academy video. This is my third video on the topic of addition and subtraction of fractions, and this is actually where we've been building up to the point at which we deal with algebraic problems. It's definitely good for you to see how it works with numbers because it's also useful there and it saves you a lot of time, but it's vitally even more important when you're dealing with algebraic problems. So I'm just going to show you one because the concept is the same as I showed you in part 2. It's literally the same. And then we'll do a post-WAG exam, which is looks slightly complicated, but it's the same exact concept. So let's just start with example 1, which is as follows. You're given this problem. X over y plus 2 over... Actually, let's start with this. X over y plus 2 over y. So we'll do 2 examples, actually. How do you add this? You're given this problem. You're asked add these 2 fractions together. What do? You do it very quickly, like I told you in previous videos. When you have 2 fractions and you're adding or subtracting them, you're carrying out addition or subtraction between them, and they have the same denominator, your result will have the same denominator. You know that. Your resulting fraction will have the same denominator. And as for the numerator of the resulting fraction, all you have to do is carry out the relevant operation on the numerators of the original fractions in the order you see them. So here we have the first numerator is x, the operation is addition, and the next numerator is 2. So we carry out the problem in this order. Literally, x plus 2 will be the numerator. And you leave it like that because you can't simplify any further. And I'll go to example 2, which will have an algebraic problem where you have to add fractions with different denominators. I hope you guys do realize that x over y is a fraction, even though it's not a number. It's not in terms of like numbers, explicit numbers like 1 and 2 and stuff, 3 and 4, like real numbers. It's still a fraction because it has a numerator and has a denominator. And at the end of the day, this x and y could be a constant or variable. I actually haven't defined it, but x could be 1. I could tell you x is 1 and y is 2. So it could be more recognizable as fraction in that form. But fractions which just involve variables do exist, so you need to be aware of them. So this problem is just as follows: x over y minus anything z over g. These are just variables, random variables, and to solve them you just first of all need to solve this problem. You just need to realize that you've been given 2 fractions with different, and just make that clear, different denominators. Denominator of the first fraction is y. The denominator of the second fraction is g. So what do? You write the fractions so that they both have the same denominator, and just use what I told you. Pick the first fraction, multiply through by the denominator of the second fraction, g, and that gives you xg over yg. Go to the second fraction, multiply through by the denominator of the first fraction. So denominator of the first fraction is y, so you multiply through by y. So by multiply through, I mean multiply the numerator and the denominator, if that's not clear. So I'll say that again. If I say multiply z over g through by y, what I mean is multiply the numerator and denominator by y. So this gives you zy and gy. By the way, gy is the same thing as yg, because we are saying g, then just rewrite that. And then just make this clear. Gy is the same thing as saying g times y. If you've done algebra, sorry about that. Gy is the same thing as saying g times y, which is the same thing as saying y times g. 2 times 3 is the same thing as 3 times 2. It's the same thing going on here. So by the way, that's g, which is yg. So just note that gy is the same thing as yg. So what we've done here now is we have x over y, and we've written it as this xg over yg, and the other fraction was z over g. Wait, hold on, that doesn't make sense. Actually, yeah, it does. The other fraction was z over g, and we've written it as zy of gy, which I said is that's a mistake, not a mistake, but I meant to write the gy as yg. So we have 2 fractions. The original fractions have been written in 2 different forms, and so if you just forget, just go back to the original problem. What we've done is now rewritten it as this: xg over yg. So what I'm saying is xy, x divided by y is now the fraction x over y is now xg over yg. The subtraction sign stays. The fraction z over g is now zy over yg, as I showed you. So this is getting a bit clumsy here, but I'm just going to change the color to blue so you know I'm continuing from this. So how do you subtract these? Well, they have the same denominator, so I know the denominator of the solution is yg. In terms of numerators, I just carry out the relevant operation on the numerators, and boom, that's it. So as you hear, you have the first numerator is xg, you have subtraction sign, and you have the next numerator zy, and that is it for you. That is the solution to the problem. The answer, and put it this way, the answer to this, is this. Okay, now a past exam question, like a Y question that came out in 2013, which may look slightly more complicated, but I'll just put it in red just so it's an exam question. This was a question I asked 2013. I can't remember what. It's in the objective test. 2 over x plus 3 minus 1 x minus 2. So you have two fractions. Again, they're fraction because each of them are fraction because you have a numerator and denominator term, and you're asked to simplify them. As you can see, the denominator of the first fraction is x plus 3. The denominator of the second fraction is x minus 2. These are clearly different. X plus 3 is not x minus 2. So what do? You may rewrite them so they have the same denominator. Now, imagine having to do the LCM problem here. I mean, again, I think that procedure is just long. I think an easy thing for you to do is just say, well, all I'm going to do is rewrite the fraction as follows. I'm going to write the first fraction as follows. I'm going to multiply the first fraction by the denominator, by the denominator of the second fraction. And I'm going to multiply the second fraction by the denominator of the first fraction. So by the way, that's x. That's times, and this is x. You can see where I write x and the multiplication sign are different. X is curled while the other x isn't curled. So all I've done is multiply the first fraction by the denominator of the second one and multiply the second fraction by the denominator of the first fraction. That's all I've done. Now I'm just going to simplify. Now I have 2. Okay, I should go down. I have this. X plus 3 times x minus 2. I'm not simplifying anything yet. I have 1 times x plus 3 is x plus 3. So all we're just trying to do is have two fractions with the same denominator, which you do now. As you can see, denominator of the first fraction is x plus 3 times x minus 2. Here. Denominator of the second fraction is x minus 2 times x plus 3, which is the same thing as x plus 3 times x minus 2. So let me just make that crystal clear. I mean, when you're multiplying things, you can write them in any order, provided they're just multiplying two things. So another way to say it is a times b is the same thing as ba. You need to know this in case you didn't know. But I'll just get out of the way. So x minus 2 times x plus 3. This denominator here is the same thing as x plus 3 times x minus 2. So now you can see that the denominators are literally exactly the same. So you know when you subtract these two fractions, the denominator of the resulting solution is going to be the same as the original fractions. And the numerator is just going to be 2 times x minus 2 minus x plus 3. Then you can simplify further. So by this stage, you need to know how to multiply out fractions. I'm going to assume you do. I guess my main point of this video is just showing you how to rewrite fractions to have the same denominator. I'll probably have a video lesson on algebra and doing multiplications, but for some of you who already know, I mean, 2 times x minus 2 is 2x minus 2 times x minus 2 times 2, which is 4. And then you have this minus x plus 3. I'm just going to leave the denominator like this. And when you simplify this, you get x minus 1. And that's your final simplified answer. But to be honest, from I mean, this is just the point I wanted you guys to get to, just to get to the point where you started with the original fraction. Oh, wow. Okay, I should use a different color for this. You started with the original fractions, where the original fractions have different denominators. You use the procedure I explained in, part 2, and I use, for example, 1 and 2 above, and you just multiply the first fraction by the denominator of the second fraction, multiply the second fraction by the denominator of the first fraction, and you just simplify, and you see that you have the same denominator. X plus 3 times x minus 2 is the same thing as this, because this is x plus 3 times x minus 2. So I just rewrote it clearly so you can see now you have two fractions with the same denominator, and you just carry out the subtraction. The result will have the same denominator, and the numerator is just, well, the first one minus the second one. You can stop there, I mean, for the purpose of this video, but if you are actually in the exam, you'll have to simplify it and get to this form. But thanks for watching, and have a good day.